Last time, our tap became a number. DNS, the domain name system, translated the game's name into an address. But when it arrives, it walks into a surprise. Behind that single address, there is not one server, there are thousands. And every one of the millions of players tapping right now races toward the same front door. So who decides which server handles your tap? Meet the busiest traffic cop on the internet, the load balancer. Here's why it exists. One server, no matter how powerful, has a ceiling. It can only hold so many connections before it slows to a crawl and falls over. The only way to serve millions is to run many servers and split the crowd across them. But that splitting cannot be random chaos. Someone has to stand at the entrance and send each request to a server that can handle it. That someone is the load balancer, and every request enters through it. The Journey Map subway line from last episode, phone to resolver to server, now zooming into the server stop to reveal a traffic cop labeled load balancer standing before a row of many identical server machines. So how does it choose? The simplest method is round robin. Deal requests to servers in order, like cards. First to server 1, next to server 2, then 3, then back again. Simple, and it works surprisingly well. But it is naive because it assumes every request is equally heavy and every server equally free. In real life, one player loads a huge race replay while another just checks a score. So smarter balancers use least connections. Instead of taking turns, send the next request to whichever server is juggling the fewest active connections. The balancer watches everyone and feeds the one with the most room. But here's the question that reveals its most important job. Servers crash. One freezes at 3 in the morning. If the balancer keeps dealing requests to a dead machine, thousands of players hit a wall. So how does it know a server has died? Pause and think about how to detect it. The answer is the health check. Constantly, quietly, the load balancer pokes every server with a tiny question. Are you alive? A healthy server answers instantly. The moment one fails to answer a few times in a row, the balancer stops sending it traffic and spreads that load across the survivors. Players never notice. If this echoes the Sentinel watchdogs from our Redis series, you're seeing the pattern. Good systems assume machines will fail and route around them automatically. We solved the crowd by putting one traffic cop in front of many servers. But that creates a scary new question. What if the load balancer itself dies? Have we just moved the single point of failure? Real systems answer this by running more than one load balancer, with a backup ready to take over the instant the main one fails, so the front door is never a single lock. Scale one thing, and you almost always create a new thing to scale. That tension never fully disappears, and you'll see it throughout this series. So here's the big picture. One server cannot hold the world, so we run many and place a load balancer at the front door. It spreads the crowd using round robin or least connections, uses health checks to detect dead servers and route around them, and is itself made redundant so the door never closes. Our tap has now reached a specific healthy server, ready to be understood. But that server does not want to do everything itself, and there is one kind of request it would rather not handle. The heavy stuff, images and videos. Those get served from somewhere much closer to you. And that's next time when we meet the Content Delivery Network.